for your immensely informative, Dr. Rao. Now, we are going in for the keynote address of the day. Professor K. Muralidharan, sir, the professor and former head, Department of Population Research Center, MS University, Baroda, is also the Director, Population Research Center of the university. A recipient of various prestigious awards, including the Distinguished Statistician Award instituted by IFPS in 2018 and the Writer Excellence Award for publishing a bestseller book on Six Sigma with Springer in 2015. He's a life member in various prominent statistical associations around the globe. An expert in statistics and probability, he's a highly cited researcher around the globe. A person of immense repute and knowledge, he's beyond doubt an apt personality to handle today's topic. We are extremely honored by your presence, sir, and I welcome you to deliver the keynote address. Please, sir.
Thank you very much, madam.
Thank you.
Thank you. Okay. Good morning to all of you. Am I audible? I hope so.
Yes, sir. Yes, sir, you are audible.
Okay, right. Please let me know when to increase the voice or decrease the voice. You can tell me at any point of time.
Okay, sir.
So here is my presentation. I'm just starting my presentation. It's already on the slide show mode. Can you see all of you?
Yes, sir.
Okay.
Yes. Sorry, yes, we can.
Okay, fine. So it's better all of you please mute your microphone. All of you please mute your microphone so that there will be no other disturbances. Okay, once again, good morning to all of you. I take this opportunity to congratulate Kerala Statistical Association for taking a lead in celebrating World Statistics Day 2020. I hope so. I think this. I've seen a lot of advertisement and the webinar call from different, universities and institutions. I think this is the first to begin with. So I'm so proud and so I feel honored that I'm giving a talk on this particular occasion. So thanks to Professor Sadish Kumar, President of KSA, Das George, Secretary of KSA, Subha Nair, and other office bearers of KSA for giving me an opportunity to give a keynote address in this particular celebration. And at the same time, I would also like to express my gratitude to Professor Shankaran for inaugurating this particular webinar. So with that particular note, let me slowly get into the topic of today's discussion. And just one or two slides just to make you comfortable with what World Statistics Day stands for, what are the significance of World Statistics Day 2020, etc., etc. So let us see with some basic information about this. You know, we are going to celebrate third World Statistics. This is the third one because it all started from 2010, I think. Yes. And 2015 we had the second, and 2020 we are going to have the third one. So it's just 3 days away from now. So the theme of this year's World Statistics Day 2020 is connecting the world with data we can trust. And the website is already shown, also you can see that. And the celebration of World Statistics Day 2020 is a global collaborative endeavor organized under the guidance of United Nations Statistical Commission. So you can understand the importance given by the global community leader, United Nations organizations for promoting statistical activities across the globe. Okay, now just imagine the theme. Suppose the theme would have been connecting the world with data. Suppose it stops there. Then definitely it is going to be a general theme. Anybody can talk about that. And if, in fact, everybody talks about data. So if that is the case, then there is no need to mention a statistician's role in analyzing or bringing data into in the world. But the last three words, we can trust, I think that is the importance where statistics community is addressed. So please note the importance of the theme for today. So for this one, this webinar, the World Statistics Day. So connecting the world with the data, we can trust. We can trust. I think only the statistician can bring data quality, and they can only bring data in the finest form, and so that we can trust the data and the analysis and interpretation, whatever comes after doing the analysis part. So there's a lot of importance given to statisticians across the globe. Okay, so that is one part of it. Second part is the logo of World Statistics Day. So there are two types of logo they have published. You can get into the website. I said I have already shown there. So there are two types of website. I mean the logo. So one is square type and the other is the circular type. The circular type is used for promotional activities. And if you see the logo, there is a circle you can see that stands for the globe, and the three spikes. Maybe it looks like yes, of course, it is a bars. Okay, subdivided kind of bars with a spike, a tick mark. So that stands for the trusted security. And this is the importance of logo used for this year's World Statistics Day. So please understand the importance of data in that particular aspect. So how do you bring the trusted security? Because we know we are all playing with data every day. A lot of data there is no dearth of data now. So data is everywhere. So data is everywhere. So in fact, the amount of digital data that exists is growing at a rapid rate, doubling every 2 years. This is according to IBM. That says 2.5 billion gigabytes of data was generated every day. Now you can imagine the massive amount of data coming out. Similarly, an article by Forbes states that the data is growing faster than ever before, and by the year 2020, about 1.7 megabytes of new information will be created every second for every human being on this planet. This is huge, and we are already experiencing the same. One of the best examples is the corona-related, COVID-related, virus-related data we are getting. It's already piling up. So far, there is no leeway. When is going to come the vaccine going to come? When is going to be the antidotes experiment is going to come up? We are not sure about. But data is coming up every day. Every day the data is, adding up. So it's going to be huge. By now itself, the data has become very, very big. So what do you mean by data and statistics? Very, very important. Data from a general perspective we are talking about. We know we can very well, we are all statisticians, and we can very well define data in the best, finest form. So anyway, this is how we always perceive data as. Data are individual pieces of actual information recorded and used for the purpose of analysis. And it's the raw information from which statistics are created and generated. And this is many often is used as a result of, for the interpretation as well as presentation. So it's the importance of data. That's the reason why data, everybody is using statistical information or statistical theory per se. So we cannot forget, because data is everywhere. And we have to live with data now. And data explosion and data exploration is going on now. So that is the reason why, one of the reasons why people are using mathematical and statistical science. Because the competition is increasing. Now business process, business delivery, business methods are changing. Service, even manufacturing process, everything is changing. Altogether, there is a paradigm shift. If you look at the talk of the title of my talk, I'm going to talk about the paradigm shift. Where is the fundamental changes taking place? So I've discussed slowly into that particular point. Deregulation, consolidation, and increased competition are also forcing them to reevaluate their technology and business process. It's not the way the people are doing business till 2020, maybe even last 2010, for example. Last 10 years, we have seen the improvement or even the increase. There's a data explosion because of computing technology. There is a data explosion because of scientific explorations. There is a data explosion because of innovations. That's why it's becoming a mandatory for all business organizations to change their processes. Because the technology is handy, and it's becoming a part of their activities. It's very, very important in that sense. Even changing regulatory demands, for example. Regulatory demands are changing every now and then. Tariff issues, for example. Environmental concerns and health and safety issues are also changing and putting a lot of pressure on this business guys. Okay, climate change issues we are all aware of. A lot of climate change issues are now, incorporated in the business activities and service-related activities, etc. So the need and urgency of developing statistical and analytical skills among executives for data analysis and project management implementation has been rapidly increasing. So it's a very important phenomenon now seen. Project everywhere, people are doing projects. So in every aspects of activities of organization you can see there is a project execution, project management. So project management is a very very common activities now. Everybody knows it. Now the question is, how do you carry out a project management in the best possible way? That is where the statistical science, even mathematical science, also comes in. We cannot forget mathematics when you talk about statistics, because we can't live without mathematics, because mathematics is required, no doubt. There is no doubt about it. But we will come to know where how the changes are taking place in mathematical and statistical sciences. So over a period of time, if you see the statistical science, for example, even in the hierarchical form itself, we started with the usual data analysis or statistical analysis. Then it changed, we have biostatistics, actual statistics, computational statistics, bioinformatics, etc. Data mining, for example. We are now, the last 10 years, we have started talking about data mining concepts. Data means nothing but knowledge discovery of data. Then there's a concept coming up that is cryptography, blockchain concepts, etc. Very, very powerful technique where cryptocurrency, Bitcoin concepts are also coming up. A lot of statistical programs, statistical methods, and information technology-based algorithms and programs are written for this thing. So artificially creating, currencies. Okay, no physical form, only digital form. So there's a lot of statistical comparisons, associations, etc. are done on that particular subject. And of course, data analytics is a topic which we have been hearing for last many years. Business analytics, big data analytics, data science. So please note, all are different, not all are same. This is also a very important thing. One should know. Because I will also discuss the differences between those data analytics, big data concepts, etc. The same way there is something happening in mathematical sciences also. But the way the statistical science have grown over a period of time, that's not happening in mathematical sciences. Of course, there are changes. Number theory, a lot of new, features and new ideas are implemented. Okay, this is also, related to this Bitcoin concept and the cryptography concepts, etc. Dynamical systems, for example, mathematical biology, computational mathematics, biomathematics, just like biostatistics, we have biomathematics, quantum gravity studies, okay, gravity study, relativity studies, etc. Things are happening. So no doubt. So it's both the subjects are growing and both, they are taking the help of information technology and at the same time, both mathematics and statistical science is also combining their effort to form new concepts like even cryptocurrency. I already mentioned blockchain professionals, forensic sciences, computational biology, structural biology, evolutionary biology, DNA sequencing, mapping, networking, etc. They are all combined with the mathematics and statistics. Okay, so definitely there is a lot of importance for mathematicians and statisticians. You can also become a statistician, can also become a part of Make in India and the Startup Initiative. Please note that this is not to bring any political statement here, but at the center, even DST is promoting a lot of initiative, Make in India, and the Startup Initiative, where they are offering a lot of projects and programs and incentives for or starting or executing projects. So youngsters can definitely look into this kind of apps. I think those who are joining the universities or college, this education system as assistant professors or so, they should look for definitely the carrying out projects of various kinds. So okay, where I can bring all this, the new concepts where artificial intelligence and machine learning concepts are also adding up, because with that only the subjects are now giving, transforming to a new level of subject disciplines. So please understand that. And here is a beautiful diagram, this is a beautiful illustration, for example. We all believe that mathematics is a very big community, okay, but the requirement is very, very small. Okay, we can see mathematicians everywhere, but the requirements, and you know what is the job prospects for mathematicians? Very limited. Of course, there will be teachers. One can become teachers. That's right. But how many colleges, universities, even in schools, for example. Then these days, people, the university, UGC, and all funding agencies are asking people to reduce the number of intakes, for example. So definitely, the appointments are now reducing. And even in that appointments, if you see the importance of mathematicians as well as statisticians, definitely statisticians' appointments are going to be less. So look at that. There's a different scenario now shaping up here. So you have a huge, community of mathematics, but the requirement is very less. And it is completely reversed in the case of statistics. Requirement is very huge, whereas the community is very small. And every time we, even for job appointments, for example, there's a call for a large number of statisticians in various positions. I'm not talking into what kind of the designation I'm not talking about any designations per se here. But look at the requirement. It's very huge. So there's a lot of transformation taking place from mathematics to statistics. If you see, I think the best course offered, I mean, one should look for is statistics course. No doubt. Even if you look at the payment structure, if a mathematician is getting a payment and a statistician getting a payment in private organizations, it is much higher than all mathematicians or even MBAs and IT people. So this is the situation now. So I think we all should promote the importance of statistics in our school, even in school, even colleges and universities. I think we should make them understand. We should have a collaboration. We should have a discussion with the people, maybe the stakeholders, for example, maybe a stakeholder of a school or a college or university. We should make them understand the importance of statistics. It is going every day. And next few years is going to be a terrific, a kind of situation going to shape. And we know that why statistics science is important. Again, this is the only reason. Because we got talking about uncertainty. Because every business activities or any of this service process is marked with uncertainty. So there's no control of the variation which is coming through the uncertainty, and which is generally coming through process or product variations, etc., etc. So we should, and this can be very well addressed by statisticians. And probability is considered to be a measure of uncertainty. We all know that. Probability models, most of the time business models are probability based. And because they rely on, they trust on statistical models because of this reason. And there's another is, and you know what for the statistical science is used. I don't want to read all those things. And the reason is quite simple here. Look at these two models. We always talk about y to the f of x. Okay, so y is the process model. So y is the output, x is the inputs. X can be many, there can be many inputs also. So the process connecting y and x is the f of x. So it can be a mathematical relation. Generally, determinist models are generally mathematical models, right? So it is always a mathematical model. Okay, so we talk about linear, non-linear, or any kind of exponential logarithms. No issue. Okay, we can always talk about a well-established deterministic model, and that's generally considered to be a mathematical model. Once you consider an uncertainty model, changes altogether. The process model changes because of the presence of epsilon. You can see the second term, epsilon. So what is this epsilon? That's what is called, we call generally a nuisance term, error term, random term, uncertainty term. It's a lot of terms associated with epsilon or epsilon. So the presence of this makes the importance of decision making for business guys. Okay, so that is why it is called statistical model. Okay, now you can very well, from this relationship, you can very well make an assessment about which is going to be the generalization. So in fact, statistical models are generalizations of all other models, business models. Where mathematical model is also becoming a particular case of statistical model, because there is a presence of epsilon in the statistical model. And if epsilon becomes zero, you are back to the mathematical model. So I found many platforms, even conferences and the seminars, many senior professors of mathematicians and statisticians are talking about these kind of situations. Where they say that mathematics is actually a particular case of statistics, not the other way. We believe, so far we have been believing that statistics is part of mathematics. You may treat it in any way. There can be many similarities and commonalities. That's a different issue. But statistics is not the general, the statistics actually is a generalization. So mathematics actually is coming as a part of a subset of statistical model. So look at this is very, and we always talk about f of x plus epsilon, and you know how to treat epsilon. And that's the whole problem. And the whole problem of statistics comes to the treatment of epsilon. Okay, we have to put some assumptions regarding epsilon follows normal with so on. That depends on what kind of situation we are going to analyze. If it is a regression model, definitely we talk about epsilon follows n 0 sigma square. Okay, and if we are talking about some other sense or some other context, we will have to change the assumptions for our epsilon. And these days people talk about epsilon follows non-normal also. And accordingly, definitely there will be a complexity in the model. And the complexity is not a problem for statisticians or even mathematicians now. We have now very good computing powers possible. We can write programs. We have softwares available, and very decently we can talk about how the epsilon should be. So that's not an issue at all. So please look at this particular point. Even I'm requesting all the students participants of this particular webinar, please pay attention to this point. Statistics actually coming as a generalization of the whole science, mathematical science. Okay. And of course, the purpose of statistical science is specifically for problem solving. Okay, logical developments, very, very important, logical development. Okay, this is very well addressed through statistical principles and etc. We can remove complexity of the problem. Definitely, we can also have decision making under uncertainty. Okay, so the purpose of statistical science is very clear now. Probably that is the reason why statistics is now coming up in new shapes and new forms. The new, many challenges as well as applications and opportunities are coming up in statistical science. So let us look at that. Maybe one of them you can see big data, for example. Okay, so as far as the company perspective, if you see the SAS Institute, the president, vice president, or executive vice president SAS Institute, according to him, John Saar is the co-founder and executive vice president of SAS. He says big statistics is the term that deals with a lot of data and statistics that are important and significant. Please note, he coined the term big statistics, not big data. Okay, big statistics, and that makes more sense, right? Being able to take big data and turn it into big statistics is important for genomics, industry, and business. And people are always now, genomics is a very big area now. It's altogether shifted. Earlier, it used to be a part of botany and geology, zoology and all those things, biological sciences. Now it's altogether a new discipline now. Industry and business are where big statistics is important. People always talk about statistics. Okay, so here statistics is not simply an information; it's actually a measurement-based information. Actually, that's the importance of the statistics, big statistics. So it's a fact that industry has recognized. Please note, it's a fact that industry has recognized the increasing importance of practice of statistics to solving the complex problems faced by business, industry, and government and ITs. Even government industries also, government sector altogether is a service sector. Look at banking, for example, insurance, for example, all service sectors, for example, they are also interested in this. In fact, the big data concept originated from their applications on. So there are a lot of potential for that. And there's another company, McKinsey and Company, for example. They foretells a shortage of up to 190,000 workers with deep analytical skills and 1.5 million managers and analysts to manage data projects. So you can imagine worldwide what is happening. And large number of these workers will be going to be holders of bachelor's degree in statistics. So the vacancy out of 190,000 coming up for data management projects, a large number of them are going to be bachelors of statistics. So can you imagine where is statisticians of that much number? Just imagine Kerala, for example, how many colleges and universities offer statistics course and how many people are graduating and even post-graduating every year. Just to make a count of it. At the same time, take a count of the same graduates from mathematics department. You can see the difference. I have already explained that in one of the diagrams. You can very well say that. And please understand the importance of statistics, and this is the time to promote statistics. So when you talk about World Statistics Day, definitely there is a dire need of statistical promotions across the globe, and we also need in our own country also. Okay. Now, if you look at the Indian perspective, for example, there is a huge demand for data analytics professionals in India. And the analytics, data science, and big data market size in India reached $3.03 billion in 2019, last year. And it's expected to double by 2025 as per the report AIM and Praxis Business School. Just imagine, there are many organizations looking after the Indian context also, how the data science is growing up. Please understand one more thing. We, the Indians, are very good at data analytics. Our mathematical aptitude is much, much better than any other persons or people in the globe. So probably that is one of the reasons the people are now saying that India can become a capital of data analytics, for example. I will show you a report given by one of the big businessmen. So I will just show you that also in reference to one of the slides. And Bain & Company recently highlighted in its report that the Indian advanced analytics talent pool, which was 65,000 in 2018, will reach 2 lakhs by 2020, by this year means in just 2 years. Just imagine, it's growing. There is a complete exponential growth, like we have already seen COVID-19. The infection rate is going exponentially. The same thing happens, even much very sharp increase in the number. And the domestic IT companies leading the analytic ecosystem in India, like Tech Mahindra, TCS, Genpact, Wipro, HCL System, etc., they are contributing 35% of analytics outstanding in market. So just imagine the perspectives for statistics students. Okay, and what is the potential? Because the next going to be the next frontier for innovation, productivity, and competitive advantage. And that's the reason. So please understand, big is I have placed it in the bracket. So just for the time you can even keep away that. So just put it in a silent mode. So data analytics, the potential, because it is going to be the next frontier for innovation, productivity, and competitive advantage. And that is the reason why everybody, even social science people are now using big data concepts. Okay, science people anyway using social science, then economic science people, even business management people, market research people, they are all using big data concepts or data analytics in general. And big data is often defined as more data possible by the internet, and every time somebody uses a wireless service. And of course, that's what's happening. Just imagine the amount of data generated through wireless communications, for example, data generated through your own mobile instrument, for example, data generated through say, for example, healthcare, for example. It's huge everywhere. Every time the data is generated. Okay, and it's now growing by. Now we are talking about gigabyte. Now people have started talking about terabytes and petabytes, for example. So the next one is going to be terabyte. Okay, so you can imagine how much information we are now transferring, accessing, releasing, and disseminating, and it's all going to become a common practice in the near future. And statisticians have all the responsibility to take care of these issues. Okay, it's going to give a revolution, or it's going to explode like anything. It's all about big data. It's all about tapping data into diverse data sets, finding and monetizing unknown relationships, and therefore completely a data-driven process. We cannot talk about big data without statistics. People may claim that IT people can do big data, mathematicians can big data. Please know that's wrong perception. Without statisticians, you cannot talk about anything about big data. So the coverage, as you can see, is huge. You will see that the diagram also, it shows lot many things are happening now. Okay, so people are using customer profiling, segmentation, lifetime value analysis, sentiment analysis, satisfaction. Look at the data generated through WhatsApp messages, for example. Look at the social sites, for example, Facebook, Instagram, Twitter, for example. Lot many informations are analyzed. Now we can now the election related analysis have already started. US, I am talking about US election, presidential election, for example. See the big data, since now everybody is going to talk about, everybody is going to become a part of this data revolution. Forecasting analytics, utility analytics, telecommunications, etc., recommender system, fraud analytics. It's now touching almost all forms of life. Okay, there is no area which is not touched, not covered in this. Okay, and the challenge is at the same time, when you're talking about a big, definitely there are going to be definitely some challenges also. So the question, the first most important thing is because of its unstructural nature and textual. Most of the time the data is textual, not in numbers. Numbers will be there, but very few. But how to convert that factual and textual information in terms of numbers? And after only getting numbers, we can talk about some analysis. Generally, the statistical tools applies only for numbers, generally. But actual and qualitative analysis also there. Okay, please don't mind that there is no, statistical analysis is not possible for qualitative. But we have a number of tools for qualitative analysis, but very limited when you compare with quantitative analysis. Another important challenge is the information management itself. How do you cater? How do you manage the information? Where do you store? So, like I already mentioned, gigabyte is now slowly transferring to terabytes now. Okay, so far we have pen drive, for example, of 64, 128 GB also. Even 256 GB also available. How far? How long? What are you going to make? How are you going to? So, what are additional changes you need? Okay, that means every time you are also generating data, every time you also need to store the data. Okay, now fine, storing may not be an issue. For example, we have cloud computing facilities now, we can keep somewhere artificially. So that's not an issue now. The problem is again, how do you manage? Where do you store? Suppose you want to access the file in Excel. Excel also have limitations, for example. That is the only frequently used software we use. So where do you again access and accession and only after accession you can do the analysis. Again, analysis per se, if you talk about, you cannot do the whole the file in one go. So you need to classify, you need to segregate, you need to partition the data. Only then you can make the analysis possible. So there are a lot of issues now. Then similarly, the high performance analytics. Where do you get the software, for example? Now people are okay using Hadoop, for example, for handling big data. Then Python language is again, I mean, frequent now. People are using artificial intelligence and machine learning techniques where you need that kind of software, etc. So that's okay. Again, limitations are going to come. Data is not going to stop here. It's going to increase again and again in future. So definitely we will have to find a lot of facilities and a lot of issues. I mean, this thing in future. So and of course, definitely the whole quality of the data also will be lost. So that is another big challenge: quality of data. So to analyze tools for analyzing such a kind of data and making interpretation based on the analysis become a very big challenge for people. So definitely statistician, mathematician, IT professionals also should work together. That's only a solution now. Okay, and that's the reason why they are coming together now. Many departments in the universities have combined data analysis. They may say data science sometimes. Department of Data Science, Data Analytics, or something like that. Statistician, mathematician, IT professors are working together. Okay, so now another question, which generally people ask, even during my own, this thing lecturing, sometimes people ask, who can be a good scientist, data scientist, for example. So I would say that my answer is, first of all, he or she has to be a statistician or a mathematician, but with additional qualifications like good knowledge of computer technology, software handling efficiency or software operating efficiency, and management skill also should be good at, and a good communication skills. If that is the case, you can be on top. There is no other profession which can beat this profession at this particular point of time. Okay, so those students, especially those students, participants, I'm talking to them. If you are thinking of becoming a good data scientist, please try to be a good at computer. Your software handling efficiency should be good at least one or two software you should be thorough with. Similarly, you should have a good leadership skills. Through that only you can develop management, leadership, management, good manager. You can become a good manager with that. And of course, you should also have a good communication skill. And when you talk about good communication skill, definitely it's English is now the worldwide internet language, for example, or computing language. So computer language or computing language, talk about it and say definitely you should improve your grammar and in English communication also. And most importantly, we always generally go for appropriate analysis. Instead of that, you should give a kill kind of, now the situation is like that. You have to provide ultimate analysis over appropriate analysis. Most of the time we do data analysis in the classroom exercise. Okay, maybe in the project sometimes, maybe in the classroom exercise itself. So most of the time we go for appropriate analysis. Okay, for a given situation, we see what type of data it is. Whether it's continuous, we have a series of data methods, collection analysis method. For a discrete data, we have accordingly, we have methods for that. So we always look for what is best, what is the appropriate analysis for. But instead of that, you should now provide, you should be able to provide, if you are a good data scientist, you should be able to provide a ultimate analysis over appropriate analysis. This is the requirement of the time now. Okay, now what is the difference between big science, big data, and data analytics? Data science is the field that comprises of everything that related to data cleansing, preparation, and analysis. And big data is something that can be used to analyze insights which can lead to better decision and strategic business moves. And data analytics involves automatic insights into a certain data set as well as suppose the usage of queries and data aggregation. So you can just imagine the previous slide we have talked about who can be a good data scientist. So if you have a good management skill, leadership skills, communication skills, good at computer, etc. So definitely you can be placed somewhere, maybe in data science, maybe in big data, maybe in data analytics courses. They're all different because the job profile will be different because organizations are different. Definitely job profiles also will be different. If you are working with the TCS, definitely the profile of TCS will be different from the Pro, for example, Infosys, for example. Definitely. But please note one more thing. Analysis, when you say analysis or analyze automating insights, okay, just see the other colored words. Please, that is where you need to be good at statistics or mathematics. Of course, you have to be good at statistical analysis. And why? And the usual analysis. What is the difference between data analysis? This is another question which is quite often people ask. So what is the analysis? What is the basic difference between data analysis? Maybe you can say it's usual data analysis and the big data analysis. Okay. So what is the difference? See, most of the time we always, I mean, the classroom we always talk about normality concepts, normality, independence, structure of variables, random variables, etc., etc. And if you are working with the time series data, we always talk about stationarity of the data, etc., etc. So these are the assumptions which simplifies theoretical constructs. We have a very strong theoretical base, and that was possible because of these assumptions. But again, now this is the scenario is changing now. You cannot have, in big data concepts, you cannot expect the data to have normal form, data become independent, and the data, most of the time they are unstructured, as we have already mentioned. And therefore, the data may be dependent on each other. A lot of issues are going to be there. Quality of data, missing data, a lot of issues will come when we talk about big data. So there is a basic difference. So the earlier in the usual analysis, when we teach the class, so we always have something in our, there is a specific questions in our mind. But this is not happening when you talk about big data. The challenge for analyzing big data is coping with abundance. Abundance means too much, volume, exhaustivity and variety, and timeliness and dynamism, velocity. So we always talk about, big data, people always talk about velocity, veracity, volume, etc. There are 5V, 3Vs, etc., etc. I don't want to get into all those issues now. So please refer to some online materials or textbooks for that kind of information. Okay, so my focus is to make you understand why data analysis or data analytics and statisticians are important in the current situation. Okay, so for this, for challenge, for facing the challenge for data, big data, there is a lot of issues associated with its volume, variety, and etc. So there is no specific question in mind actually, and generally it comes as a byproduct of something else. Okay, so please refer to these papers by Miller and Kitchen for some more details on this. So it's very, very interesting thing. So there's altogether a structural difference between the usual data analysis and big data analysis. Okay, so there is in the usual data analysis, there is some specific questions always in mind. So we always try to answer that. So that is what is becoming a part of the decision making. And in big data analytics also is used for data decision making, no doubt. But the problem is that there is no particular or unique questions which we generally keep in mind. Okay, so where are they used generally? So we have already mentioned at various point of time. So data science, you can use it in digital advertisements, search engines, documented systems, etc., etc. Big data, of course, you can use it in financial services, communication, retail, data analytics. Is there? Healthcare analytics becoming a new branch now altogether. Okay, gaming, for example, you're all famous gaming. A lot of games are now available on. I mean, you can play online also. So in mobile applications, you can have that kind of. It's official now. It's official. Travel, energy related, etc., etc. So what are the skills you require for each one? Data science, big data. So as I told you, we have made it very clear that they are all different. They are not sick. Okay, and interestingly, you will see data science become the top. Even the payment wise also that becomes very, very high. And you can see that now whether it is data science, big data, data analytics, statistical skill is a must. Okay, and plus other things, maybe management skill, maybe knowledge of computer, program, etc. R programming, of course, most of you are now good at R. Please keep on reading, keep on working R programming and introduce R at least in the college and university curriculum. For all practical purpose, I think you should get into R or SAS or something or some other things. Okay, so definitely for big data, you can have creative thinking is another. You should have a creative thinking. So that's, of course, Indians doesn't have need any special mention about. We are very good at data analytical skill. Our logical reasoning is very good. Creative thinking is very good. Okay, that's the advantage of Indians. That's the reason why they are into IT professional kind of this kind of fields more. Okay, so that's the reason why people say that the next destination will be for all this big data related science. The next destination is going to be India, for example. Okay, and data analytics, of course, programming skills and all the other things, such as etc. Yeah, you should also have good at visualizing skills, data intuition, etc., etc., etc. And if you see the payment, for example, you can see there's altogether different. Altogether, it's a high payment for data science people. Okay, if you see the big data and data analytics, for example, it is just double up. Data science people are offered higher than any other people. Big data is next one, then data analytics next one. And it's changing every year now. Even the big data professionals are paid. In India also, they are paid very heavily now. Maybe the best payment is offered for the scientific and the people of this expertise. And of course, we cannot deal out. I mean, without this discussion, we cannot move on. So artificial intelligence, because the altogether a different career is now coming up with AI and ML. So AI stands for intelligence demonstrated by machines, in contrast to the natural intelligence demonstrated or displayed by the humans. So we have a natural intelligence. So how do we, bring intelligence to machines? That's where the artificial intelligence works. And similarly, machine learning is actually a subset of artificial intelligence, actually. It's a scientific study of algorithms and statistical models that computer systems use in order to perform a specific task effectively without using explicit instructions, relying on patterns and inference instead. So a lot of statistics are coming in this particular area also. Because when you talk about inference, especially when you inference in totality, it's all going to be statistical inference. We can only provide estimations, predictions, and all issues related to the values in what to and to depend on, etc. etc. So it's seen as a subset of artificial intelligence. And there's another subset which is coming, that is what's called deep learning. I'm sure all of you are familiar with deep learning. So deep learning is actually a subset of machine learning. And machine learning become a subset of artificial intelligence. So there's a hierarchy here also. So you can become an artificial intelligence professional, you can become a separate machine learning, can also become a separate, a professional in deep learning also. So definitely a lot of scope for mathematicians and statisticians to develop professional, development. So please, so maybe those who are into the academics, again, they have the scope, they also have the scope, and plus the students who are coming up in the education for statistical education also have a good scope. So as per many reports, for example, TOI, Times of India reported last year only, just a year ago, AI being one of the biggest opportunities in India today. And only 1.1 to 2% of India's workforce in the tech and financial sectors have AI, ML, and data science knowledge. This is the scenario now. Only 1 to 2%, so low. But it's going up now. It's now increasing, now reaching to a new position now. And according to LinkedIn, about 7 out of 10 emerging jobs in India are tech-focused roles hinged on AI and ML. Now imagine. And definitely all social media related, sites, they use a lot of AIs and ML type of algorithms for analyzing their, business, to promote their business activity. Okay, so even according to LinkedIn, they say ML engineers being the top, we are topping the list. Similarly, NASCOM, according to NASCOM, emerging job roles in AI include data architect, applied scientist, ML speech vision analyst, business intelligence, and developers, developing engineers, etc. A lot of new areas and designations coming up also. So please look at all these reports for further understanding of the situation of AI and ML careers in India. Even there's some reports says that there are about 40,000 AI professionals so far in India, and 10 companies, the most AI professionals in India includes Accenture, TCS, Cognizant, Infosys, Wipro, IBM, Microsoft, Amazon, Capgemini, and SCL Technologies. Okay, now many other companies are now getting into the AI element. Next 2-3 years, you will come to know altogether new names of companies and organizations. Number of companies setting up dedicated AI teams in India is also increasing by about 30% year to year. And average work experience of AI professionals is so far 6.6 years. You can, this is because, this is of course, this is last 10 years only it's all started. So the average work experience is now 6.6 years. It's very natural. Okay, and around 3,700 freshers were added to AI workforce in 2018. Now that is increasing now, and Bangalore becomes the lead. I mean, taking all the lead in appointing AI professionals. So there, and the next one comes 22% from Delhi. That is Gurgaon. Yes, Gurugram area. And 48% of AI professionals have a master's or postgraduate degree in statistics. Maybe 5% they hold doctorate degree also. That means there is a potential for all. You don't need to, even if you have a PhD, you don't have to stay in education if you want to shift to a private organization where you feel like you are suitable for, if with a good knowledge of AI and ML and with some other good knowledge of this, definitely you can move to private jobs also, where you can get a lot of interesting payment, not even compared with any other professionals in the industry now. And the median average, median AI salary is 14 point something lakhs. Okay, so 14.3 lakhs across all experience levels and skill sets. It all depends on how much you can deliver. It all depends on that. Please, knowledge is very important. Knowledge is very important. And these days, the problem, the new generation, I'm talking about new generation people, there is no seriousness in studies, and they get grades and marks and etc. That is because of the evaluation procedure. Most of the university is now liberal to the evaluations, etc., etc. Even the way of conducting the examinations, they show all kinds of liberality and etc., etc. So new generation people should take care in this particular. See, they may be good at, but they may not have established knowledge in the subject. So they may be getting 90% or more. They may be getting higher grade, but that doesn't mean that their knowledge level is good. So what you need to do now is you should improve your knowledge level in statistics. That is very, very important. In the earlier situation, the earlier generation, we don't need to specify this. They are very serious about, we know, the way they used to learn. Even the researchers, for example, they depend more on the physical books and library books, reference materials, etc., etc. They often read journals, magazines, etc. But these days, people have altogether changed. And we all know that, why, because it all changed. So the digital methods of learning has altogether changed the perception of our the education. So that, especially for the new generation people. So they should be very good at knowledge development. Okay, they may be good at technology. Yes, I believe that they are good at technology, but that's not enough. They have to be very good at knowledge. So that's very, very important. So look at this, another report. So I found a lot of reports for presenting this particular presentation, for preparing this presentation. I refer to many contemporary journals and newspapers, etc. So I found a lot of reports coming up on AI, importance of AIs and ML in India also. This is another report again based on Indian context. You can see Bangalore is topping, then New Delhi, then Mumbai, then rest of India. When you talk about the appointment of professionals in data science, etc., or data analytics, etc. Okay, even the segment-wise, the pie diagram, sorry, the net diagram, if you see, you can see the maximum percentage people are employed in banking and financial sector. Then comes the pharma sector, then e-commerce, then energy, then telecom, like that. So that means it's covering almost every field of science, management, arts, commerce, business, etc., etc. So there's a lot of scope for people who are coming up for statistical education, etc. Here is another report which was again reported last week only in the Mint. In the Mint is an online report, a newspaper kind of thing. They reported Data Sun's chairman N. Chandrasekhar, and he says that India has potential to become AI capital in the world. And AI and AI-based solutions should be used for the common man instead of centering around software professions and data scientists. So this is another area where one should look for. Okay, so combine the professions, for example. Okay, you can even, there are now even UGC is promoting the idea of multidisciplinary curriculum, even interdisciplinary research and interdisciplinary curriculum. etc. And a lot of things are happening at the higher level also. So why they also started thinking on that particular line? Because they know the importance of data science coming in the future. So they don't. They in every cases they want to connect with the data science related courses. They want to make all the entire curriculum based on the data with that perception. That's what the change happening altogether. So that's why there's a paradigm change. Okay, so again, I'm slowly coming back to my topic of the title topic, the paradigm shift. A lot of paradigm shift is taking. Altogether, the fundamental changes are taking place. And AI and AI-based solution, according to N. Chandrasekharan, should be used for the common man instead of centering around software person. That's also very important. That we already mentioned that. So you will have to talk about the issues related to common people. You should bring AI and ML applications in agriculture, for example. Now it is confined to the manufacturing process, it's confined to automobile process, it is confined to some technical oriented process, etc. Why don't you bring? That's what the importance of AI and ML. I have to bring to the common people. Let them use it. And definitely it is possible and in the near future. And we know that drone related aspects. The drone is used in everywhere. It's completely working on these kind of algorithms and etc. etc. So and definitely I'm see miniature versions of innovations and ideas are coming in many forms. And of course, that is his contribution. Statisticians are contributing across the world. And according to him, developing a policy framework will accelerate development of AI and AI-based solutions in a significant way. Maybe he's asking the government to come up with some policy decisions in this regard. So of course, there's going to be something. So what is the paradigm shift ultimately? So revolutions in science have often been preceded by revolutions in measurement. Okay, so a lot of things are now happening. We know science have over a period of time had a lot of changes. Okay, so the complete paradigm changes and shifts we have seen. Okay, so that is definitely going to happen further also. Okay, so now, so it's all based on measurement. The new paradigm, the new shift is happening in terms of the measurement base. So, and big data creates a radical shift in how we think about research. Please note, it's all together changing. Probably you may need to sacrifice theoretical constructs sometimes. That's possible. I referred to many papers we found. I found many people are giving opinions about this particular issue. Means you may need to keep a theory for a time being for to the other side. Okay, so talk about the practical issues. What you want to need, you will have to bring a kill situation. You have to bring ultimate analysis, for example. Okay, we are not looking for appropriateness. Appropriateness we are familiar with. You can even analyze through even Excel software also. But the situation is different now. We have big informations, big data, for example. So that's why we need to bring a radical shift in thinking process. It offers a profound change at the levels of epistemology and ethics. Epistemology is also knowledge base. We'll have to change the knowledge base even in and ethics. So maybe sometimes you may forget about the theoretical concept. That's why the ethics comes. So most of the time in the classroom teaching, we always talk about theoretical base. Okay, based in theory, we promote the practical. Of course, that is needed. We cannot forget about theory, even central limit theorem. We cannot forget about that. Without that, there is no existence of statistics. We always talk about, if you do sampling and sampling, definitely sample mean ultimately should also go to normal. So that is somewhere going to happen. So whenever you start analyzing the big data also, maybe you need to segment, maybe sometimes you'll be extracting some information and you will have to check whether there's a possibility of normality there or not. And big data reframes key questions about the constitution of knowledge, the process of research, and how we should engage with information. That's very, very important. How we should engage with the information. Okay, so what type of information we are getting, whether it is qualitative or quantitative again. Whether in quantitative, what type of quantitative type are we talking about, discrete or continuous, etc., etc. Again, further detailing scale variables, ratio type, that all types of issues will come up. Okay, because many of when we teach statistics, the way we come across with the data, we always tell the students that, see, this is how the data is coming up, then definitely we should use this kind of tools, etc., etc. So probably you may need to change that particular perception about that. So maybe you will have to sacrifice theoretical concepts sometimes. So it's okay. That's okay. That's not a big issue now. But the issue is not sacrificing the whole theoretical background we want to achieve something. That's not my point of this convention. So it takes out new terrains of objects, methods of knowing, and definitions of social life. So it's slowly connecting, getting connected with the social life also, and that is the importance of shift, the paradigm shift now happening. So the need of the hour is to make data-driven analysis rather than knowledge-driven science. So we have seen over the last many decades, for example, it's knowledge-driven. So change, make it data-driven science, so that you can address the societal issues. You can address the issues faced by nations. You can address the issues of related to economy and so, in the society and the nation, for example. You can talk about culture, for example. We know culture. When we talk about culture and traditions, etc., etc., we always talk about we have factual information only. We don't have any measurement-based information actually. But many of us we don't even like to have that, in the measurement-based. But time is that we need data-driven analysis rather than a kind of knowledge-driven analysis. So look at another interesting comparison of paradigms for last many years, many decades, for example. So far, according to many others, these two I have found very prominent. According to them, there are four paradigms we have. Over a period of time we have. So first we have experimental science, then theoretical science, then computational science. Now we are talking about exploratory science. So experimental science earlier, the first, before Renaissance period, it used to be empiricism, empirical based. Some evidence we need, always look for. Then to describe the nature of phenomena, that's how the things goes on. That's how the decision is taken. And then get on to theoretical science, where modeling and generalization came into being. That is pre-computer EDA. So that is what the time where you can imagine 50s, 60s, and 70s. So most of the time we talk about modeling and the generalization. So just imagine most of the theories of mathematics and statistics and all other subjects per se, it all came during that period of time because people started doing the modeling aspects and generalization, etc. Then came the computational science, where people started talking about simulation of complex phenomena. And we know that for last 20 years, for example, 20, 30 years, starting from 90s onwards, not many things have changed because of the increasing trend of information technology. So that is actually pre-big data. So big data not started. So big data, if you see, it is all from last 20 years. People started talking about big data from 2000 onwards. So before that, it all was simulation. And definitely when you talk about simulation, which is all about statistics, okay, generate data through various probability distributions, okay, then fit a model, artificially create a model, then talk about what is going to be the population, what is going to be the general situation. So samples are generated through simulations, and that's why people take decisions and talk about the situation. So complexity of the situation is reduced because of simulation, and people still use simulation, and simulation is also becoming a very big part of big data analysis. Even artificial intelligence and machine learning, when you talk about simulation, you cannot forget about. So it's a lot of applications of simulations. So new inference also, that's the reason why we all know that Bayesian inference and Bayesian research is now booming up. It was not there till 1900s, for example. Hardly people talk about 1900. But people talk about this Bayesian inference till 1900s. But last 20, 30 years, you see, maximum research is now coming up in Bayesian related research. Because we know Bayesian definitely get into all kinds of computational complexity, and that is possible now. We have very high-end computing facilities available, software is available. Even we can write down programs and etc. Even our programs, our softwares are now coming to the help of analyzing. Any kind of models, whether it is posteriori, or priori, or any kind of models. So the fourth one, the latest, is the exploratory science, where data intensive. It is becoming more and more data intensive, and statistical exploration, data mining is happening every time. And that's the reason that there's going to be an order of change. And definitely we have to face this challenge in the near future. And this is happening now. So please face this particular data explosion. Okay, so lot many things are happening for the betterment of statistics. Please know, this is only for statistics. The entire now new things are happening. Everything is changing, no doubt. Every subject has changed, every curriculum has changed, everywhere changes are happening. But all these changes, I feel strongly that all these changes are for statisticians. So what you need to do now, it is time to wake up and be a part of data revolution. So be a part of revolution, data revolution. So with that, I will stop here. It is 11:57. I was given 45 to 15 minutes, 50 minutes, but I told Professor Sadish Kumar that I may go up to 1 hour because I prepared this particular slide for 1 hour. It's almost 1 hour now. So I think it's time to stop here. Thank you very much. Thanks. Questions, please.
Yeah.
Any questions, please?
Uh,
I strictly followed my timing.
yes, sir. Thank you, sir. Please, anyone, please post your queries in the chat box.
Yes, that can also be done. They can also connect with me also. They can also send questions or any queries to my email communication also. And plus, at the same time, I mean, they can interact with, you people also. And if you feel that there should be something, some explanation is required, then you can also send to me. You means the Kerala Statistical Association. So by closing, let me also thank once again the Kerala Statistical Association for taking a lead in celebrating World Statistics Day 2020. Okay, so I am becoming a part of this. Probably the first presentation on this particular celebration happening before the 3 days in before. So okay, thank you very much. Thank you very much once again. So here are some of the references.
Yes, sir. Actually, a query has come up in the chat box, sir.
Okay, please.
Alekhya Sharma, she's asking, can you tell me the difference between MBA data science and MSc statistics?
MBA data science and MSc statistics. Oh, okay, that's a good question. Uh, there is no answer in 1 or 2 minutes I can complete, but I need a lot of discussion. But still, quickly, let me give some insights on your question. So MBA data science definitely promote management concepts, and they will not be working too much on theoretical aspects of as we usually do in the statistics class. So MSc statistics is a full pack with theoretical theorems and results, and where with all fundamental concepts of statistics will be discussed. Now, to be very specific, the coverage of such papers, coverage of courses in MSc statistics will be definitely different from the coverage of courses in data science of MBA. They may come up, they may be interested only in business case related problems. I don't think they even a data science course of MBA will discuss anything about testing or hypothesis related issues or this thing, etc. They may be using it. So to be very frank, I think MBA data science course may be more practical than the MSc statistics. This is the only answer which in a short answer which I can provide. Okay, so there will be a lot of difference, lot of difference. I have seen number of MBA's course materials, curriculum of various universities. So MBAs generally they don't discuss too much of statistics actually. So to have a good flavor of statistics, definitely you should have a knowledge of theory also.
Oh, thank you, sir. Another query almost on the similar line has come up. What is the difference between applied statistics and big data analytics?
Oh, okay.
Kushik Kapadia
All
has.
this big data, the analytics, or this is all applied statistics only. This is all applied statistics. Okay. Now, when you say applied statistics, we have a perception that it's a usual statistics course offered at MSc level, with some where most of the context will be practically analyzed, and that is how that applied statistics concept goes in. And most of the time applied statistics course involves most of the papers, like for example, inference papers will be the stochastic process related papers will be the sampling and multivariate techniques related papers, and that goes. And generally applied statistics course generally don't discuss measure theory or real analysis on that kind of mathematics. But in mathematics, but in MSc statistics related course, definitely mathematics courses are 2 or 3 papers of mathematics papers also will be included. Okay, that's all about that. Now, when you talk about data science course, the difference between applied statistics and data science, definitely there will be a lot of difference. Means it's not going to be completely a statistics course taught in data science course. So science course is going to be a kind of IT, that means information technology related, but the computer related course will be more, maybe it may not be more, but in equal number. For example, statistics course, maybe some papers, maybe 5-6 papers of mathematics, of 2-3 papers of mathematics, then 5-6 papers of a mix of, I mean, IT. So that is how it is going to be. Data science course is going to be. So you can see that the structure, when you talk about the structure itself, there will be a changes in the course. So that is how I think it differs, actually speaking. So don't be in the same impression that they are same, not same.
Okay, sir. Another question by Shyam Nair. Is actuarial science more beneficial than big data analysis or applied statistics?
Okay, that's another good question. Now, actually, science is an altogether a different science. Okay, where mathematics, importance of mathematics and importance of statistics is equally at par, and actuarial science is generally used in finance and insurance kind of service related fields, and there the course materials, definitely there are a lot of probability based materials to study in the actuarial science. So I think you should not compare actuarial science with a data science course as such. So there is no, I strongly feel that it should not be compared. It's altogether a new discipline, new area of profession also. Altogether a new area of profession, actuarial science, actuary, a person who did a kind of, say, 10-15 papers of statistics with maybe 5-6 papers of mathematics and all those things. So IT, that is, see, data science, when you say data science, it's a mix of all the three disciplines, mathematical science, statistical science, IT. So when you talk about actual science, I don't think IT, the relevance of IT may not be that much. Okay, it is there, no doubt, but better not to compare an actuarial science course with a data science course.
Okay, sir. Thank you. Another doubt is by Gopa Chitapathy. How structuring of the unstructured big data is being taken care of?
Oh, that's a very big challenge that's a challenging question for me. Okay, now we have already mentioned it's very difficult to make it a structured, because big data generally comes unstructured and textual and factual. So to have a structured form, you need to extract the useful. Maybe you will have to carry out a data mining concept first. Understand the basic structure of the data, whole data. Then maybe you extract, save it in a different form, save it in another way, and maybe try to reduce the dimensionality through data mining first. Then after that, probably you may be in a position to make it structurized. Maybe in that case, once you are in a structurized form, definitely you can address statistical principles. You can apply very nicely. For example, normality case, that independent structurized, all those things you can bring it. So data analysis, big data or data science, and all analytics pay attention to. It's not in a single go. You cannot have a single analysis. Please understand. It's a multiple analysis performed. Okay. So while doing this, you will have to structure. You may, if you feel that if the time warrants, if the context, if the situation warrants, then you can structureize it. It is possible. Okay, so that's where you should have a very good computing facilities available. Even nowadays, one of the challenge we have already mentioned, that is there is no such software where a complete data, big data, which has terabytes of data in the data set to analyze it. So having a good software for that is the first challenge. So if you are able to then I think better to have some data mining tools carried out. That is easy now. Data mining tools, data mining softwares are available freely. So maybe you carry out a data mining investigation first, then you try to structureize. And I think that is the only answer now.
Okay, sir. Another doubt is that even though these artificial intelligence and data science are emerging fields, why is it that the institutions offering such courses are very less? The question was put up by Anita Joy.
Yes, that is what where people at the helm of FAs, for example, For example, our Shankaran is Vice Chancellor, for example. Now, there are many of my, even Professor D.T. Shuke is the Vice Chancellor of Shivaji University. Very recently, he was appointed. What I mean to say is the people at the helm of affairs should convince the authorities. Okay, they should come up with a model that yes, this kind of courses is very much essential for social science people, for arts and science and the other commerce, humanities people, etc. If they can convince the people definitely there will be an impact. So that people will start slowly thinking of introducing data science courses in their curriculum. So maybe that kind of development, if we are able to address at the authority level, probably this question, whatever now we have posed, can be resolved.
Yeah, true, sir. Another question by Radha Salim. What can a UG statistics degree student do during the time of the course to become a data analyst in future?
Yes.
It's a
Okay.
very valid question for
Okay.
students.
Now, what you need to do is, please try to see almost all statistical tools discussed in theory, I mean textbook or reference in everywhere. You have an exercise part. You have an exercise in every chapter, for example. Try to do all those exercises to the principles discussed in that particular chapter. Please make a kind of, please fine tune your mentality towards practical questions. And same way, you also encourage the students to find a similar situation which is discussed already in the class, in the textbook. So please try to, maybe artificially you can create that situation. Okay, so have a data which they can work on instead of data which is taken directly from the textbook, from that exercise section. Have a data set. For example, I always take an example from, I mean, generate data in front of the student. Just for example, to give a simple insight. So your mobile instrument, for example, now it is allowed everywhere. So without mobile, you cannot live. Now you can see. Once I told my students, you please, what kind of data you can generate. Then I told with some hint also I gave. Then they started bringing. See the call duration, for example, number of call duration, etc. So I told them to start preparing an Excel file itself. So start. What is your first variable? Okay, number of calls. What is the next variable? The call duration. What is the number of calls received? It's another one, etc. Now, in this way, in this process, we were able to find out 25 to 30 variables in an Excel file. It's what very easy and it was very lively. We could do this exercise in the class. We did it. So what I mean to say is make students perceive situations where data can be generated in the class. I think data generation in this new current situation is not that difficult. You should encourage. And slowly, that particular process will slowly develop. That students will start thinking various practical situations to generate data. So that is the only way. So that by the time they this should be started in the first year of undergraduation. So by the time they complete 3 years of study, statistical study, I'm sure that definitely they will change their perception towards the statistical course. Okay, this is the only way.
Okay, sir. Actually, there is another question, similar question from Archa Mukesh. I think she's a +2 student. So the question is, I am a biomath student and I wish to proceed a career in statistics. What can I do? She's from +2, I think.
+2 student, biomathematics student, it's excellent. Where is this course offered?
Yeah, biomaths is CBSE and ICSE are offering it, no, in
Oh, I
+2.
do. They have, I say maybe
Even state.
they may say A group, A B group
Yes.
and B group or
Yes.
something like that. Okay, yeah. Okay, that's excellent. Well, definitely. So her question is how to
She
how
wants a
to.
career in statistics. She's asking your advice on how to achieve it.
You see, it's very simple. That +2, she can join with some good university for undergraduation where data science courses are offered. There are many colleges now starting undergraduate course in data science also. Okay, or if not, it's better to join for a statistics undergraduate course that will be there, or even mathematics undergraduate course that also will be there. So it's better to join a mathematics or a statistics undergraduate. If not, there is no data science course available. In that case, let her complete the undergraduation in any of this. After that, I think after the graduation, there is a lot of scope for going for specifically on data science courses.
Okay. Okay, sir. Thank you.
And the opportunities in near future, next 2-3 years, is going to see a lot of revolutions happening in the statistics curriculum. Lot many universities are going to start new programs in undergraduation also and post graduation also. So it's better. I think her question is very relevant. She should join for an undergraduate course in statistics or mathematics.
Okay, sir. Another question by Pavan Kumar Gupta is, how can we increase the role of artificial intelligence-based accounting systems?
Artificial intelligence accounting is.
Yeah.
See, increasing means now there are a lot of online courses available. Okay, there are some institutions also started artificial intelligence courses formally. Some IITs also started. Some other private institutions also started. So I'm sure that this will be percolated into other university system also. Now, right now, what he can do is he should join for, if possible, he should join for a regular AI related course. That's first thing. Or else, if he is working, definitely he can go for some online courses. Okay. To be very frank, I also did an online course from, conducted by IBM. Okay. So I know the course material is really good. So that's one thing. Now he should join. Now, an accounting system, for example, that's correct. It's a very good question. He's altogether a different discipline. So he should do he should first complete a small, maybe a diploma program, maybe a certificate program in AI course. If that process, he will come to know the application potential in the accounting system. So definitely that is the only way for the time being.
Okay. Another question is about the statistical tools used in big data analytics. Bindu has asked regarding the statistical tools used in big data analytics.
Oh, what is
Can you please tell me about the statistical tools used in big data analytics? That is the
who are talk, the boy or girl? Boy or
it's a
girl?
girl, Bindu.
Bindu, okay, Bindu,
Yeah.
sorry, Bindu. Now, is she graduated or post-graduated? Can you tell me that?
I don't know, sir. Actually, it came in the chat box. If Bindu is there, she can interact directly. Is she there?
Bindu, can you tell me what is your background?
Sir, I did PhD in statistical techniques in bioinformatics and microarray from St. Thomas College, Pala. Currently, I am working as assistant professor in Department of Statistics, Government Arts and Science College.
What a
I
surprise! You are already a data scientist. You are already did a PhD in this kind of course.
Yeah,
What do you
because
mean?
data
You
is
know the tools.
unstructured and
Yeah.
you have
See.
images and the
Okay.
steps are
Okay.
different. Data visualization tools and etc.
Of course, data visualization tools are there, data
Yeah.
aggregation methods are there, data presentation methods are there. You can use many multivariate techniques are coming. Definitely, lot of multivariate techniques for establishing grouping, cluster technique, hierarchical clustering, agglomerator, all types of clustering techniques you can use for this. So, a lot of multivariate techniques you can use. Is coming up there. So anyway, since you are familiar with or you are already a doctorate, definitely you are already familiar with the statistical tools available. All those tools can be applied. The question is how do you apply and this thing, that's the point where the significance of the question comes. So, uh, definitely if you know the procedure, definitely what type of AI algorithms you use, it all depends on that also. Okay, so I think almost all techniques, tools and techniques. Now there are many techniques like the recommender system, for example, network surveillance kind of tools available which are coming again. So you will have to think beyond a statistical tools also. That's very important. You will have to think slightly beyond the statistical tools also. There may be some tools which may be simpler than a statistical tool which can give you the best result. So that's all possible. So as such, almost all tools of statistics applies for data science analytics.
So another query is almost in the same term, sir. Dr. B.C. Nair has asked, kindly say something about statistical softwares like R or SPSS for data analysis.
Okay, oh, Dr. BC Nair, my friend, my colleague, BC
Oh.
Nair, Balakrishnan. Hello. Hi.
Hello, very happy, fine. Very happy to listen from you after so many years.
Thank you very much,
Very,
Balakrishnan.
very good information. What I want to know, many of the people are coming to us for the data analysis. So we blindly recommend them sometimes the softwares like use SPSS app. They are just blindly using without understanding the basic concept. Then what happens? They come back. They come back to us with the final results to interpret the result.
Okay.
So in this context, whether the statisticians should come forward to simplify this software, so we whether we